Good afternoon. This is me, Ayman Yassin, and welcome to the third episode, which is directed to the AS and A levels candidates. In this episode, I'm going to solve paper 5. This paper 5, it's directed only for A level candidates, but in the same time could be very helpful for AS level candidates, because it's very similar to the paper 3, which is practical part. So this paper, it's paper 5. The name of this paper, it's Planning, Analysis and Evaluation. The series is February-March 2016. So I will start with the first question. Here in this question, we have propanone is an organic liquid which is soluble in water. Aqueous propanone reacts with iodine, and this reaction is catalyzed by acidic ion, hydrogen ion, and the balanced chemical equation here, it's written in the question. The order of reaction with respect to iodine can be determined experimentally. So in this experiment, we are going to determine the order of reaction respect to the iodine. An experiment is carried out using the following solutions. You have 25 cubic centimeter of 1 mole per cubic decimeter of propanone, and you have 25 cubic centimeter of 1 mole per cubic decimeter of sulfuric acid, and 50 cubic centimeter of solution C, which is iodine, with the concentration 0.2 mole per cubic decimeter. So we have here these solutions. We are going to use all of these solutions to determine the order of reaction of iodine. The solutions are mixed to start the reaction. That means all of these solutions, A, B, and C, are mixed to start the reaction. At certain time intervals, a 10 cubic centimeter portion of the mixture is withdrawn and transferred to a conical flask containing excess sodium hydrogen carbonate to prevent any further significant reaction taking place by removing the hydrogen ion. The concentration of unreacted iodine in each 10 cubic centimeter portion of the mixture can then be determined by titration with aqueous thiosulfate ion. So, before starting to solve this question, let me draw the general idea of this reaction. So here you have beaker. In this beaker you will mix A, B, C together, which is a propanone, sulfuric acid and iodine. Okay, and you have in the same time you have stopwatch. Okay, here in this stopwatch, every for example 10 seconds or 20 seconds, that means you have intervals. After each let's say 10 seconds, you will take a sample from this mixture. You will take, oh sorry for that, you will take a sample from this beaker, then you will transfer it in another container, or let's say test tube. This test tube, it contains sodium hydrogen carbonate. Okay, you will transfer it here, 10 cubic centimeter. after 10 seconds or 20 seconds. So here you have this sodium carbonate will react with the portion, which is 10 cubic centimeter of this mixture, to stop the reaction. Why to stop the reaction? To determine the unreacted iodine. So this sodium carbonate will remove which one? Will remove the B, which is acid. So here you have again A, B, C. This is a propanol and this one is iodine. Sodium hydrogen carbonate, when will remove the hydrogen, at once your reaction it will be stopped. That means there is no reaction between A and C. In this time you can determine the concentration of C, which is iodine. How you are going to determine the iodine? So you will take this test tube again after you have removed all the acid. So here you have only A and C. This solution you will transfer it where? To the conical flask. This one here, A and C. Then you will make titration. Let me here, this one. You will make titration. In this biarate you have sodium thiosulfate, Na2S2O3. So sodium thiosulfate will react only with C, which is iodine. Here you have non-concentration, non-volume from biarate, and the iodine you have already non-volume, which is 10. Then you will calculate the concentration of iodine, which is unreacted. So then you will have what? Different concentration of iodines for different intervals times. Okay, then by drawing the graph between time versus concentration, you will identify or you will determine the order of reaction respect to the iodine. So this is general idea of this equation. So let me raise this part to use it to solve the questions. In the question A, state the size and the type of apparatus needed to prepare suitable volume and standard solution with this concentration of propanol from liquid propanol. So here what do you need to prepare any standard solution or an exact concentration of any material? Always that we have used where in the lab we have used this apparatus, and here there is a mark, and the size could be 25 cubic centimeter because you need at least 25 cubic centimeter of propanol. So you need to use this volume at least, and could be the range, that means from 25 to 250, doesn't matter which volume, but that means at least you need to use this volume. And here we have cup. What's the name of this apparatus? Its name volumetric flask. The size, it's range between 25 to 250 cubic centimeter. Then in the same question you have another part here. Calculate the mass of propanol needed to prepare this standard solution. You have concentration, propanol, yes. You have concentration, you have the volume. So First of all, you need to calculate the number of moles, then you will calculate the mass. So by using this equation, concentration equal mole over volume in a cubic decimeter. So the concentration, it's written in the question, it's 0.1, and the volume 25 cubic centimeter. So the concentration the concentration, it was 0.01, yes, 0.1. The volume 25 cubic centimeter. To convert it into cubic decimeter, that means 25 over 1000, which is 0.25, and here mole. Mole equal 0.1 times 0.25, and this one it will give us 0.025 mole of propanol. The question needs the mass, so from the mole you may calculate the mass over molecular mass. Number of mole already you have calculated, it's 0.25. The mass we needed, X, and molecular mass of propanol, actually you have 3 carbons and 6 hydrogens and 1 oxygen. The summation of these numbers is 58. So X, which is mass, equal 1.45 gram of propanol. Okay, so here we have calculated the mass of propanol which is needed to prepare this standard solution with concentration 0.1. Here the solutions A, B and C. A, it was propanol, B, it was the acid, and C is the iodine. So A, propanol, B, acid, and C, it was iodine. Now suggest the best order of adding these solutions. What's the best order? Now look at here please. The acid which is used B, it's a catalyst. It's a catalyst. That means this catalyst will catalyze the propanol or iodine. That means you need to avoid adding this acid after mixing A and C. So it's not possible to mix A and C then you will add B. Why? Because A and C, if they are together, the reaction will start, but it's very slowly. But in the presence of B, the reaction, it will be catalyzed, and the reaction, it will be accelerated. So you need to add what? Always the reactant are A and C. One of these must be mixed last. So B must be added before A or C. That means you may say A here must be added before first or the second. So you may add B, then A. So you have mixed A and B together, then you will add the C. Or you may add B, then C. At the end, you will add the A and the reaction will start. So explain why we have chosen this order, to avoid, or we don't need, so that means, how to say that? That means A and C should be mixed at the end. In the question C, each 10 cubic centimeter portion of mixture removed, as we have stated that, explained it at the beginning. So after interval of 10 second, 10 second, 10 second, or 20, you will remove 10 cubic centimeter of from the mixture, and is added to a separate solution. In this solution, we said it was containing sodium hydrogen carbonate in a conical flask to remove the H, the catalyst, to remove it. So when you remove the catalyst, the reaction will start at will stop at once. So what do you need to transfer 10 cubic centimeter exactly from the mixture? We need apparatus which take exact volume and accurate, which is we have called it pipette. It's very accurate apparatus to transfer liquids. Suggest reasons why sodium hydrogen carbonate is preferred, not sodium hydroxide. Now, sodium hydrogen carbonate with acid, what the reaction it will be? It will be neutralization reaction, and you will see there is carbon dioxide it will be produced. It's right, because carbonate or hydrogen carbonate is a source of carbon dioxide when it's reacted with acid. So when the carbon dioxide bubbles, there is no more carbon dioxide gas is produced. What does that mean? That means you don't have what? Acid. And we need to make sure all the acid is reacted with sodium hydrocarbonate. So the producing of carbon dioxide is a good indicator for us to make sure all the acid is removed. So here the carbon dioxide is indicator for us to make sure that all the acid is reacted. The second reason why we haven't, before finishing the reason one, sodium hydroxide will not produce any indicator, or will not give us any indicator or any gas to make sure that all the acid is reacted. Okay, so sodium hydrogen carbonate is better than sodium hydroxide. The reason too, if you have used sodium hydroxide is a very strong alkali, could react with sodium hydroxide, could react with propanone, sodium hydroxide with propanone, and in the presence of iodine, maybe you will have triiodofoam. So this one, it will it's a disadvantage. That means you will react with the propanone, and we don't need to be reacted. And also sodium hydroxide could react with iodine also. So while sodium hydrogen carbonate doesn't react with the propanone and iodine, only with acid, and that we need it. So always we have preferred to use sodium hydrogen carbonate instead of sodium hydroxide. The unreacted iodine in each 10 cubic centimeter portion of the mixture is titrated against this concentration 0.1 mole per cubic decimeter of aqueous thiosulfate ion to determine the concentration of iodine in the mixture at time that 10 cubic centimeters was drawn. As we have stated, after you will take the 10 cubic centimeter from the mixture, then we have added this solution to the sodium hydrogen carbonate to remove the acid. Then you will take this mixture to make to determine it the concentration of iodine by making a titration with biuret, which is filled with thiosulfate ion, according to this equation. So this question I, a 10 cubic centimeter portion of mixture is removed at time 0. That means here in this time iodine hasn't reacted. This is before any of the 0.2 mole per cubic decimeter iodine solution had reacted. That means it's not reacted right now. Calculate the volume of thiosulfate. So here the reaction between this one and this one. You know, the concentration of iodine at the beginning of the question of iodine, here it's iodine, we are talking about the iodine, it was let me check it please. Concentration of iodine, it's 50 cubic centimeter, volume 50 cubic centimeter, and the concentration 0.2. So here the volume it's 50 and the concentration it's 0.2. mole per cubic decimeter. Then you took from the mixture, which is contain A, B and C, only 10 cubic centimeter. Here the volume is totally different now. That means this 10 cubic centimeter has different concentration. Different concentration here you have. So this iodine, the new volume it's 10 cubic centimeter, and this 10 cubic centimeter you took it from where? From 100. You took it from 100 cubic centimeter. So to calculate the number of mole of iodine in this 10 cubic centimeter, you need to follow this equation. The volume that you took it, it's 10, and this 10, it was from, what's the total volume of the mixture? You started to mix 50 cubic centimeter of iodine, 25 of cubic centimeter of acid, and 25 of propanol. So the total volume, it was 100 time the concentration, it's 0.2, and this concentration you took it from 50 cubic centimeter. To convert all the cubic centimeter to cubic decimeter, you need to divide it over 1000. So this one, it will give us this number of moles, which is 1 power minus 3 mole of what? Of iodine. So iodine 1 minus 3. According to the balanced chemical equation, the ratio here 1 to 2. So the number of moles of thiosulfate, it's 2 minus 3 mole. So now you have the number of mole, and the question is asking about the volume with this concentration. So now you have the number of mole, you have the concentration of thiosulfate, just you need to find the volume. So volume, concentration equal mole over volume. So the number of mole, volume equal mole, we say 2 over the concentration, which is 0.1. Point 1. So at the end you will have 10 cubic decimeter, and if you need to convert it into cubic, here the question in the cubic centimeter, so that means you need to multiply times 1000, so the result it's 20 cubic centimeter. It's a little bit complicated, but you have to practice on this question, dear students. Okay, so in the question double I, let me remove this part. Here in this experiment you have titrate, or you made titration with iodine and thiosulfate. Put it in your mind, always when you have this reaction iodine with thiosulfate, according to this chemical equation, always you need to use this equation, you need to use starch indicator, starch, which is the color change, it will be from very dark blue, or we can say it's black or blue, to the colorless. In the titration, state two variables which must be recorded in this experiment. Always in this experiment you are calculating the rate of reaction. So here you have time, and the units is second, and the other one, it's the volume of what? Of thiosulfate, because volume of the thiosulfate, it will be changed according to the concentration of iodine, and iodines, that means the amount which is unreacted, or that means when you need more of volume of the thiosulfate, that means you have more of iodine, that means you have more of iodine which is unreacted. So you need to repeat this experiment many times. So here volume of S2O3 thiosulfate ion, and the units volume cubic centimeter. State one other variable which must be controlled in this experiment here, temperature will affect on the experiment here. The temperature, its effect on the temperature will affect on the rate of reaction actually. Here the order of reaction with respect to iodine is expected to be first order. So use the axis below to draw a sketch graph of how concentration of iodine changed during the experiment. Concentration during the experiment, that means time. So here, according to this graph, so here you will have concentration of what? Of iodine, and don't forget the unit, which is mole per cubic decimeter. And here you have time, and this time in a second. Always the graph concentration of an reactant which is expected to be first order versus time should be like this one. Okay, that means is the concentration is decreased by the time. In the question II, how could the graph be used to prove that the order of reactant with respect to iodine is first order? That means why this one it's for first order? That means to prove that this graph is fit to the first order reactant, you can prove that by finding the half-life. So the concentration, for example, if it's here 1, here we can say it's 0.5, and the half of 0.5 is 25. So by finding the half-life, both of the half-life 1 and 2 should be equal. 1 equal to the half-life 2. That means here if the half-life 1 and 2 they are equal, that means you have first order reaction. A student suggests that the temperature at which the experiment was carried out would affect the order of reaction. Here, temperature and the order of reaction, there is no effect, because if you write the rate of equation equal, you have K, and here iodine. So in this equation you don't have any temperature, or that means here no effect. Temperature, no effect on the order. So by the end of this episode we have solved this full question, and we have analyzed and evaluate all these questions. So you have to practice, please, and see you in the next episode. And in the next episode we will solve the question 2 and 3. So see you again.